Picture the worst moment. Not a memory, a situation. You are standing in the open and something large has just noticed you. Not a person. Something that was here long before people. Something whose whole body is built around one job, and you are, in this instant, the object of it. Here is what your body does. It does not run, not first. For a fraction of a second before any part of you decides anything, you go completely still. Your heart, which you would expect to race, actually slows. Your breathing stops. Your muscles lock. You are, by every measure a predator uses, no longer moving at all. You have felt a weak version of this. The exam question you cannot answer. The name you forget while a room waits. The headlights. That blank, frozen, cannot move feeling is not weakness, and it is not new. It is the oldest defense your species owns, and it is older than your species by a wide margin. So why does the body freeze when every instinct says run? And why does a system built for one very specific kind of danger keep firing at exam papers and job interviews? Every layer of this gets stranger than the last, and the last one is happening in a part of your brain you cannot feel. Let's go. Let's start with the order of things, because everybody has the order wrong. You have heard of fight or flight. It is one of the most repeated phrases in all of biology, and as a description of what your body actually does, it is missing the first and most important step. Before fight, before flight, there is freeze. And freezing is not a lesser version of running. It is a separate response, with separate machinery, that fires first, on purpose. Because in the situation your body evolved for, it was the single best move available. To see why, you have to understand the animal that shaped it. For most of the time our ancestors existed, the most dangerous thing in the world was a large cat. Lions, leopards, saber-toothed cats, and their relatives were the pressure that carved our defenses. And a large cat has one weakness written into its eyes. It hunts by movement. A cat's visual system is exquisitely tuned to motion and comparatively poor at picking a still shape out of a cluttered background. A gazelle standing frozen in tall grass is genuinely harder to see than the same gazelle taking a single step. This is not a story. It is the reason so many prey animals go rigid the instant a predator appears, rather than bolting. The bolt comes later, if it has to. The first move is to become invisible by becoming still. So the freeze is not you failing to run. It is a 2-million-year-old bet that the thing hunting you is more likely to lose track of a statue than a sprinter. Now, watch what your body actually does during that freeze, because it is the opposite of what the phrase fight or flight would lead you to expect. Everyone assumes fear speeds the heart up. During the initial freeze, it does the reverse. Your heart rate drops. This is called fear bradycardia, and it has been measured directly. Karen Roloffs and her colleagues put people on a platform that detects the tiniest sway of the body and showed them threatening images. The people went measurably more still, and their heart rate dropped at the same time. Stillness on the outside and a slowing engine on the inside, arriving together automatically, with nobody deciding to do either. Why would the heart slow at the worst possible moment? 2 reasons, and both are about buying information. A pounding heart shakes the body and blurs the senses. A slow, quiet heart holds you steady and sharpens hearing and sight, exactly when you most need to know where the threat is and which way it is facing. The freeze is not shut down. It is the body going quiet so the brain can gather everything it can before it commits to a move it cannot take back. There is a faster layer underneath even this. Before the freeze, in the first 50 milliseconds after a sudden loud sound or a shape lunging toward you, the body performs the startle reflex, a hardwired flinch that pulls the head down and the shoulders up around the neck. It is the fastest thing your nervous system does, faster than you can perceive, and its shape is a clue. It curls the body protectively around the most vulnerable point, the throat, exactly where a large cat aims. You are born already flinching toward the anatomy of an attack that, statistically, will never come. You can see the same ancient tuning in what triggers it. A shape that simply grows larger in your vision, looming, sets off a flinch and a freeze in creatures across the animal world. and in human infants far too young to have learned that a growing shape means something approaching fast. Present a rapidly expanding shadow and a baby stills and pulls back. The response is there before the experience could possibly have taught it. The body ships with the alarm pre-installed and the trigger already set. And that decision is not made by the part of you that thinks in words. Deep in the brain there is a small, almond-shaped structure called the amygdala. It receives a rough, fast, low-quality version of what your senses pick up, milliseconds before the detailed picture reaches the parts of you that reason. Joseph Ledoux spent decades mapping this, and his phrase for it is the low road. A shape that might be a threat reaches the amygdala first, and the amygdala can trigger the whole freeze before you have consciously seen anything at all. That is why you are already still before you know what you are still about. The reaction beats the recognition. The amygdala does not do the freezing itself. It sends the alarm down to a structure in the brainstem with an unlovely name, the periaqueductal gray. And here is where it gets precise, because that structure is divided, and the divisions map onto distance. Michael Fanslow spent his career on a single idea he called predatory imminence. The response your body picks is not really about how frightened you are. It is about how close the danger is in time and space. Far away and merely detected, the system chooses freeze and assess. Closer, and the balance tips toward flight. Right on top of you, and it flips to fight. Fanslow and the Blanchards, working on the defensive behavior of rodents, showed that these are not moods that blur together. They are distinct stages on a ladder, and the animal climbs the ladder as the threat gets nearer. The freeze is simply the top rung, the one for a threat that has appeared but has not yet closed the distance. So you now have the shape of it. A threat appears at a distance. The fast low road fires the amygdala. The amygdala signals the periaqueductal gray. The body locks, the heart slows, the senses sharpen, and for a held breath you are a still point in the grass, betting that the eye built for motion will slide past you. There is a common misreading worth clearing up first. People imagine the freeze as shutting down, going blank, giving up. Inside it is the opposite. The first freeze is the most alert your nervous system ever gets. The body stops, but attention floods wide open. Hearing stretches, pupils widen, and the brain runs at full tilt on a single problem. Where is it? And is it looking at me? Biologists call this attentive immobility, and the name is the point. It is not a body switching off. It is a body switching everything except movement to maximum. Watch a group of grazing animals when one of them senses something. They do not scatter. They all stop at once, heads up, utterly still. A field of statues pointed the same way, every sense straining. That shared freeze buys the whole group the same few seconds of information, and only then, together, do they decide. You carry the solo version of that field of statues inside you, and it still fires in a silent room the instant a floorboard creaks behind you. And there is a reason the tuning is this deep, a reason we tend to flinch away from. For a long time, the story of human origins was a story of us as the hunter, the clever ape that came down from the trees and took over. Then, in a South African cave called Swartkrans, the fossils told a different story. Among the bones of early humans were the remains of the big cats of the time, and on some of the hominin skulls were two neat puncture marks, spaced exactly to match the lower fangs of a leopard. For a stretch of our history, we were not the top of the food chain. We were an item on someone else's list, dragged into trees and caves that were not our homes, but their larders. The freeze was not built by a hunter working out how to ambush. It was built by the hunted, working out how to still be there in the morning. You were not built to be brave. You were built to disappear. That is the whole video in one line, and everything before this was set up, because bravery, the standing your ground, the fighting back, is the last resort in your body's own ranking, the thing it does only when the other two have failed. The response it reaches for first, the one it spent millions of years perfecting, is to remove you from the situation without moving a muscle. Your ancestors did not survive by being fighters. The fighters, disproportionately, did not become ancestors. Your ancestors survived by being very, very good at not being noticed. And this is where the deep record backs up the biology, because the fear itself leaves marks we can still read. Consider what specific things frighten people with almost no teaching. Snakes and spiders top nearly every list of common fears, across cultures, often appearing in early childhood before a person could plausibly have learned them. Cars and electrical outlets, which genuinely hurt people every day, almost never make the list. A team led by Vanessa Lebu showed that people, including very young ones, spot a snake shape in a field of harmless shapes faster than they spot anything else. The mind comes preloaded to flag the exact category of threat that stalked our ancestors, and largely blind to the ones that are actually dangerous now. The fear is not a response to your world. It is a fossil of the world that built it. There is a second, slower half to all of this, and the two halves run at completely different speeds. The freeze you have been reading about is electrical, carried by nerves, and it arrives in well under a second. Behind it comes a chemical wave, carried by hormones through the blood, that takes seconds to minutes to build and far longer to clear. That slower system floods you with adrenaline and then cortisol, and it is the reason a real fright leaves you shaking and wired for an hour after the actual danger has passed. In the grass, that made sense. The threat that appeared once was likely to appear again, and staying primed was cheap insurance. At a desk, it means a 2-minute scare in a meeting can wreck an entire afternoon, because the fast alarm fired at nothing and the slow chemistry does not know that, and keeps you braced for a second wave that is never coming. The night is written into the same system. Human night vision is poor, and for most of our history, darkness was when the cats hunted, so the freeze circuit runs hair trigger in the dark. The jump you feel at a shape in a dim room, the certainty that something is behind you, the way a small sound at night lands like a slap, none of that is a flaw in a modern nervous system. It is the correct output of an ancient one, still scanning a tree line that is no longer there. The phrase "deer in the headlights" is not a figure of speech either. It is a precise description of the freeze failing in a way evolution never planned for. A deer's eyes are built for dim light, wide open to gather every scrap of it. A sudden blaze of headlights floods that system completely, and the animal does the ancient correct thing. It freezes and waits for more information, because for 2 million years the right move when overwhelmed was to hold still and assess. Nothing in that history included a 2-ton object closing at speed with lights brighter than the sun. The freeze is not the deer being stupid. It is the deer running exactly the program that always worked, against the one situation it was never built for. Which, if you have followed this far, should sound familiar. Now some of you are thinking, hang on, freezing when a lion appears makes sense, but I freeze giving a presentation and there is no lion. That is the whole problem, and it is worth saying plainly. Fair question. And the answer is that the system cannot tell the difference. The circuit was built to answer one question. Is something with the power to finish me paying attention to me right now? 100 strangers looking at you from an audience is, to a 2-million-year-old alarm, indistinguishable from 100 pairs of predator eyes. The machinery does not know it is the 21st century. It knows it is being watched by many things at once, and it does the thing that kept still-watched creatures alive. It locks the body and empties the mind, which is a catastrophe on a stage and a lifesaver in the grass. Same circuit, wrong century. So what took the grass away? The answer is simpler than you would like. We did. The threat the freeze was built for is, for almost everyone watching this, simply gone. The large cats that hunted humans for 2 million years have been pushed to the edges of the world. A person today can live a long life and never once, not for a single second, be under the eye of a real predator. The single situation the entire system exists to handle has been deleted from ordinary life. But the system did not get the message. Circuits that old do not switch off because the environment changed a few thousand years ago. They keep running, keep scanning, keep firing, and with no lion to aim at, they lock onto whatever is nearest to the ancient shape of a threat. A meeting, a test, a crowd. A phone buzzing with something you are afraid to open. The alarm was tuned for an emergency that no longer comes, so it treats 100 small non-emergencies as though each one might be the thing in the grass. Now the price, in numbers, because this is your nervous system we are talking about. Anxiety disorders are now the most common category of mental health condition on the planet, affecting an estimated 300 million people. A large share of what that number describes is a threat detector built for predators, running full-time in a world with none, firing at shadows because shadows are all that is left for it to fire at. We traded a world with real monsters for a world with none, and kept the alarm that was built for the monsters. And most of us never even knew what it was for. There is a second piece of evidence for all this, and it is not from bones or brains. It is from an experiment you can run on almost any animal, and people have, for centuries. Take a chicken, hold it gently against a surface for a moment, and it goes rigid and still, eyes open, for anywhere from seconds to minutes, then snaps out of it and walks away unharmed. This is called tonic immobility, and it is the deepest rung of the freeze ladder, the response for a creature that has been caught rather than merely spotted. It is not fainting, and it is not choice. It is an ancient automatic program, and it appears in animals as far apart as insects, fish, reptiles, birds, and mammals, which tells you it is very old indeed. The opossum, going limp and still, the one everyone has heard about, is running the exact same program. So, in a fainter and rarely triggered form, are you. The hardware for it is still installed in the human brainstem, a leftover switch for a caught animal, in a body that is almost never caught. And here's the detail I keep coming back to. That whole cascade, freeze, then flight, then fight, then the final stillness, is not a series of separate tricks bolted on over time. It is one smooth system, graded by distance, that our ancestors shared with animals we split from tens of millions of years ago. When you freeze at a bad email, you are not malfunctioning. You are running a program that predates primates, tuned by cats, inherited intact, and pointed at a target it was never designed to see. Our ancestors, incidentally, understood the freeze without a single brain scan, because they lived on the correct side of it. Every hunting culture we know of built stillness into its most important skill. The hunter who could hold a crouch without a twitch while an animal grazed closer was the hunter who ate. The same circuit that locks you on a stage, aimed the other way and brought under control, is the foundation of every stalk, every ambush, every patient wait beside a trail. Our ancestors did not try to switch the freeze off. They learned to steer it. The involuntary lock that kept a frightened human invisible is the same one a skilled hunter turns into deliberate, chosen stillness. One machine, run in two directions. You can watch the controlled version in the few societies that still hunt the old way. In the Kalahari, a tracker closing on an animal moves in a way that looks almost unnatural, flowing forward when the animal's head is down and turning to stone the instant it lifts, holding a half-completed step for as long as it takes. That is the freeze circuit, the very one that locks a person on a stage, taken off its automatic setting and driven by hand. The thing that makes you helpless in a boardroom is the same thing that, aimed the other way and mastered over years, fed a family. It was never a weakness. It was a tool we usually run with the safety off. And they read it in each other. Long before anyone could name a brainstem structure, people knew that a person could be frozen by fear, struck still, unable to speak or move. Every old language has words for it. It appears in the oldest stories we have, the warrior rooted to the spot, the villager turned to stone by a sight too terrible to process. Those are not just metaphors. They are accurate descriptions of a real state, written by people who had watched it happen and, more than once, felt it themselves. So, where does this leave you? Sitting still, with a predator alarm and no predator. Not with a flaw to fix. The freeze is not a bug in your nervous system. It is a feature that outlived its world. Every piece of it, the stillness, the slowed heart, the sharpened senses, the blanked mind, was the correct answer to a question the world no longer asks. The system works perfectly. It is the environment that changed, and it changed far too recently and far too fast for 2 million years of tuning to follow. You have a body assembled to survive the attention of something that hunted it, running in a world where the sharpest attention you will face all week is a room of colleagues and a slideshow. Most of what we call anxiety lives in that gap, between the danger the alarm was built for and the small modern nothings it now mistakes for it. And that blank, frozen moment, the one you have felt and been ashamed of, the one that made you feel weak in front of people, was never weakness. It was the single most successful survival move in the history of your line, firing exactly as designed, a few 100,000 years too late, at a threat that was only ever a crowd. So here's what I want to know from you. When was the last time you froze completely, mind blank, body locked, and could not move? Not in danger, in ordinary life. Tell me in the comments what triggered it, and whether it ever once, in your whole life, happened in front of an actual animal.